Hello everyone, my name's Keith Walton. I'm the Business Development Manager of LifeTech Engineering, and I'd like to thank you all for the opportunity to present on RBI implementation challenges and resolution strategies on established plants and new plants. My colleague, Mr. Reza Shahrivar, our Asset Integrity Manager, will be delighted to answer any questions at the end of the presentation. What I will speak about is a little bit about ourselves, then I'll talk about RBI and the stages of equipment life, our experiences with different clients, some issues with gathering data, we'll talk about damage mechanisms, a risk matrix, inspection planning, project teams, and some solution strategies. I'll summarize everything at the end. So, who we are. LifeTech Engineering is an asset integrity management company based in Aberdeen in the UK. Mr. Reza Shahrivar is our asset integrity manager. He's got many years of experience in asset integrity management. He has a chemical engineering degree and a master's in material engineering corrosion. He's working towards his PhD in life extension. He's a chartered engineer, and he has very well versed in integrity management. He's worked with companies such as Total, BP, Apache, and Lloyd's Register. Myself, I've been in Aberdeen for 25 years. I've a BA Business Studies degree and a computing degree. I've experience of general management, operations management, and business development. I've worked in the asset integrity management arena for a considerable time, and I've worked with companies such as BP, Apache, Subsea 7, and Total. The array of operators and service companies and support companies in the oil and gas industry. LifeTech. We are, as I've already said, an asset integrity management service company. We provide specialist software, consultancy, and training for the asset lifecycle. We've worked upstream, midstream, and downstream, carrying out asset integrity management assessments and RBI assessments. We have developed a suite of software to assist us in this. The modules are RBLX, our risk-based inspection software, which is accompanied by a non-intrusive inspection module. We also have fitness for service software called FITEST, and that's accompanied by our life extension assessment software called Fusion. Risk-based inspection identifies assets for inspection based on their associated risks rather than a predetermined inspection and maintenance interval. It's replaced time-based inspection in the oil and gas industry, and risks are managed primarily through inspection from a risk matrix, which gives a risk ranking for assets based on probability of failure and consequence of failure. The UK HSE, the Health and Safety Executive Report, RR 509, described 4 stages of asset equipment life, and they all have their own characteristics and behaviour and have different management and inspection and maintenance strategies. The 4 stages are post-commissioning, risk-based maturity, deterministic, which is aging, and monitored, the final stage, the terminal stage. And you would ask yourself, when should you start practicing RBI? Well, ideally as early as possible in the life cycle, and until you actually stop using the asset, until it reaches its terminal stage. So we would ask a question of, should you not consider stage 0, a stage before stage 1, and we're calling it the design and construction stage, and any new asset should start RBI at this stage. This is our opinion. So what we have done on the stages of equipment life graph that you can see here is we've added a stage, a +1, which is stage 0. And this is the new project stage, where you should begin your RBI assessments at the design stage, at the design and construction stage, to get everything ready before you actually start operating. And then that's followed by the 4 stages I've already described: the post-commissioning, the risk-based, the maturity stage, then the aging stage, and the monitored, the terminal stage. And if you can see on the graph, when you're in stage 2, the periods between inspection become shorter as an asset ages. You can see the peaks on the sawtooth reducing because the RBI method is dictating that you should carry out inspections on a sooner and sooner basis because your assets need more attention. Stage 0. If we consider stage 0, new project risk assessment, if you carry out an RBI assessment on new equipment while in the design stage, you can gain important information about how you're going to carry out RBI on an ongoing basis throughout your asset life cycle. It allows potential risks to be minimized and to have an RBI in place at the very start, at the very beginning of an asset's life. And you should follow the API 580 guidelines for this. Stage 1, the post-commissioning and early life stage. This is effectively a bedding in stage. You can see higher rates of damage accumulation and issues arising here because your equipment is actually settling into its operational life. And so you might experience service conditions, your service conditions might reveal weaknesses or faults in design, or you might have fabricated some parts of it incorrectly. For example, you might have a faulty welding procedure, or there might be some fabrication defects. And when it's bedding in, you might also find you've got installation stresses that you perhaps hadn't thought about, or you might have some mistakes in assembly. You might have some seals that don't fit, or some bolts fitted incorrectly. So stage 1 really is the early life, the bedding in stage. Stage 2, risk-based, the maturity stage, is when your equipment is actually into its operational life. It's into its stride, and you should have low issue rate and stable rates of damage accumulation, because this is the actual good operational stage. You should experience few issues arising from equipment when it's operating within its design limits at this stage. Examinations, inspections, and non-destructive testing are usually performed to ensure that the equipment is actually operating as it should at this stage. The aging stage is where your assets have been operating for a while, and you might expect some damage to accumulate, and there'll be a rate of degradation here. The equipment is older. It's showing some signs of damage and some signs of age. So it's important to determine the extent and range of damage, and you might at this stage have to look at some fitness for service assessments. Stage 4 is where it's ending. Your equipment is nearing the end of its life. Its accumulated damage is becoming increasingly severe, and equipment might need to be repaired, replaced, refurbished, or decommissioned. The rate of degradation is becoming increasingly more rapid. So the emphasis here is on maintaining your equipment safely and getting as much performance out of it as you can until it actually reaches the end of its life. At this stage, there's no guarantees can be made about future service beyond the future service life beyond the next examination. So to consider RBI at the end of life stage, it is useful, but the inspections efforts should really be focused directly on high risk areas where inspections will provide a reduction of risk for the remaining life of the plant. The high risk areas really only. Any areas that do not impact on risk for the remaining life, you shouldn't examine at this stage. So to summarize RBI at different stages of equipment life: stage 0, the design construction stage, assess equipment before it's installed. Look at any criticalities for the risk matrix for potential assessments. At stage 1, use RBI for the first inspection, following your operational standards and regulations to make sure that once it's commissioned, it's acting the way it should. And then stage 2 and stage 3 is where you have regular RBI, regular risk-based inspections through its real main core operational phase. And in stage 4, apply RBI at the end of life, but enhance it with fitness for service assessments. So RBI for new projects versus those RBI for established projects. For new projects, normally there's a time limitation here to apply RBI, because it's at the end of the EPC, it's at the end of the construction phase, and you have a restricted budget to look at RBI. You might have limited experience of RBI because you've got no data to work with. Most of the comments regarding RBI from the operator will come at the end of the construction phase, and so there's pressure to actually deliver the equipment into service. Whereas for established projects, you have an established system which can be difficult to make changes with. There's customs and practices that have been evolved over the life of the asset, and it can be difficult to move away from those. People can be busy with day-to-day operations. They'll have task overload perhaps. It's an additional tasks for plant engineers to address, and they have to integrate a lot of established procedures into the RBI system. Data quality and availability. For new projects, data should be readily available in electronic format. Drawings and data, however, can be updated during the RBI project. So you might have several different drawings to evaluate on an ongoing basis at the beginning. You might not have isometric drawings available, however, and you'll have no baseline data because you haven't commenced with RBI yet. So a lot of it is subjective. With established projects, we found that you can have low quality drawings or missing drawings. You can have discrepancy between data from your line list, your P&IDs, and your inspection reports. A lot of the information will be in paper format. You may well not have everything in electronic format. So there's a degree of formalizing data before you can commence your RBI. Damage mechanism identification and degradation rates. For new projects, there's no real data available because you haven't started your first inspections. Therefore, you have to use theoretical models and make estimations on your corrosion rates. Theoretical models also have to be used to estimate cracking. However, it's essential to record all your assumptions made for future reference. If you consider established projects, the client wants to address specific damage mechanisms. However, API 581 doesn't cover specific damage mechanisms. So you have to apply the principles in API 571 in addition. But you need to be aware that API 571 doesn't contain calculations for damage mechanisms. There will be different degradation rates and damage mechanisms present on different lines in a corrosion loop. So there's many aspects to consider for both new projects and established projects. Consider the risk matrix. For new projects, there might well be confusion between the project risk matrix, the risk matrix used when actually in the construction phase, and the RBI risk matrix for when you're actually looking at operational risk-based inspection. They're not the same. For established projects, there is no confusion about the risk matrix. You know what it is, and you know what you're working to. It's a risk matrix for operational equipment assessment. However, there might be more than one risk-based matrix, risk-based inspection matrix, because of historical occurrences. These can differ in their assessments and may lead to conflicting inspection plans. So you will have to probably customize a risk matrix to fit on your established projects. Inspection planning and first inspection. On new projects, you will need to combine RBI inspection plans with your first inspection, the normally time-based first inspection, and that can occur over a 2-year period. For established projects, it can be difficult to change historical inspection intervals built up from custom and practice over the years. Establishing time-based inspection plans used for written schemes of examination will need to be revised to address new inspection plans due to the move to risk-based inspection. It's always difficult to change established habits, so you really need to get the buy-in from senior management and all of the inspection engineers, the process engineers, everyone who's been involved in inspections and operation of the plant over time. The RBI team. For a new project, corrosion engineers play a critical role because they need to identify, in their experience, the potential damage mechanisms that they might encounter and their potential effects, the corrosion rates on equipment. In contrast to this, the established projects relies on the inspection engineer, who plays a critical role in reviewing inspection histories and determining where to pay attention for future inspections. Project durations. We find that for new projects, there are shorter projects due to readily available electronic format data, and you also haven't got any inspection reports generated because it's a new plant. It's a blank canvas. So data gathering can be easier and analysis can be easier, but there's a lot of subjective viewpoints here because it's a new plant. Established projects, they can be longer because we find that there could be a lot of data unavailable. There might be a lack of data quality and inspection reports might be missing. So data gathering for an established project establishment of RBI can take longer. Solutions. For a new project, we would recommend to use a good RBI software with the ability to calculate theoretical degradation rates. Establish connections with future operators as well as the contractors to make sure that everyone has a rapport, that everyone knows the reasons for doing your RBI. Consider time wasted for revision of any work due to new documents evolving. Once you've commenced assessment for RBI, there might be new drawings, there might be replacements of parts of the design. So you have to be careful that the current information you're using is the most up-to-date information that you will have, and that it's not liable to be replaced by alterations. Ensure that the first post-commissioning inspection requirements are considered in your RBI plans, and establish an experienced team, especially the corrosion engineer. Consider established projects. We have found that creating a joint team between contractor and client is the best way to go. Involve the inspectors, the corrosion engineers and process engineers from the start. Make data assumptions for low risk equipment to save time. Concentrate on the high risk areas. What we have also found is that, if you use representative dead legs for assessment of all dead legs, that saves time and concentrates efforts where it needs to be. The same goes for representative knowledge. Do as many tasks in parallel as you can to save time. And we can't stress the importance of using an experienced team, particularly, as I've said before, inspection engineers. So if I can summarize, RBI can be done for all stages of equipment life. Ideally, RBI should be addressed at EPC stage, stage 0. However, there's challenges for all stages. Whatever application you do, have a robust strategy in place for every stage and define and agree clear scopes of work. Be realistic in your aims. Consider all issues and challenges and have a competent software that you can rely upon. Have a competent team that you can rely upon. Have regular review meetings. Hold lessons learned. Just make sure that everyone's in agreement. And above all, present and discuss your RBI results with your technical authorities and management and agree a future program of work. Thank you, everyone. Thank you for listening. If you've got any questions at all, my colleague will be pleased to answer them. Thank you again.